Alright, so let's move into the third type of the denominators, which says the non-factorizable denominators for your partial fractions. So in this case, we've worked with the factorizable denominator kind, which is not so different from the first kind of partial fraction denominators, which is the one with linear denominators. That we've worked with all of these in the past. We've seen different methods and all for solving, but now we want to talk about the non-factorizable denominators, the denominators that you can't factorize. How do we work with them? So in order to work with it, we are going to take a couple of examples of how they look like and what we are going to and the general form of our solution. So let's carry on. All right, so imagine if we had something like this. Let's say we have 2x squared plus 3x plus 1 over, say, we have x plus 5, and we have x squared plus 5x plus 1. This is your normal partial fractions that they want you to do. Now, the reality is that the numerator doesn't matter. So we're just going to deal with the denominator. You look at it like, oh, okay, you know what? This your x plus 5 is still a normal case that we've always had. So we still have it to be a over x plus 5 because this is the simple linear case, your type 1. The number we are giving to the type does not matter. It's just for us to understand what we are saying. But if you look at this now, your first thing is that, oh, this is quadratic. And when you see quadratic things, quadratic denominators in your quadratic expressions in your denominator, you may just want to check, oh, is this factorizable? That will be your first guess to check if it was factorizable. And if you look at this now, x squared plus 5x plus 1 is what we are going to use to check if it is factorized, if it could factorize. Factors of 1 which will add up to 5, that is not possible because 1 is just 1 times 1, and 1 times 1 plus 1 is 2. This is a 5. So we know that this is not factorizable. So how do we handle this? This way we do it, we always make it something like this: your bx plus c. So it means that when we are doing the entire thing, there will be a term with the x. X is just because a lesser n minus 1, your power, which is 2 minus 1, gives us an x. Then we have a constant term like that. So in this case, we are having, the product of, let's say we divide this x squared plus 5x plus 1 by a polynomial, like we are doing the division of a polynomial, and we know it is not a factor. We are going to have a result like this. We could almost try it if we want. I guess we should. Let's say we know that x squared plus 5x plus 1, and we divide it by x plus 1, for example. I don't know if x plus 1 is going to be a factor, or we know that it's not factorizable, so definitely it's not going to be a factor. So if we say x squared divided by x is going to be x times x is going to be x squared plus x. By the time you subtract, you have x squared minus x squared is 0, 5x minus x is 4x, then plus 1. So 4x divided by x give me a 4. Now 4 times x is 4x. 4 times 1 is a 4, I guess. Oh, sorry. Okay, this is 1 here. Okay, I was one that made a mistake. All right, so that's a 4 here, and this is a plus. And this says we should subtract. So we have 4x minus 4x is 0. 1 minus 4 is a minus 3. So we confirm again that this is not a factor. And most importantly, that's not what I care about anyway. What I care about is the form of our results. There will be a term which you take x, just like your bx, and a term which will be constant, which is your c. So because we don't know what that result could be yet, we have to represent it with our dummy numbers, which is your bx plus c. Right, so that's why we have our result like that. So bx plus c over x squared plus 5x plus 1. So it is important for you to understand how your result could look like, because that will determine your work. And always check that your quadratic equation is factorizable. If it is not factorizable, you work like this. If it is factorizable, you will factorize it and work like this case that we've been doing so far, like this case where we have a and b and factors like that. So that is the important take away from here. Let's show you another one, because this is just one that of the many shapes that this could look like. So let's look at another one, another form of this. So let me just put this in a box because we are not really making use of it. We just needed it for illustration purposes. So let's say we have okay, the numerator doesn't matter, so we could always have it like that. So let's still have let's say we have your 2x squared plus 3x plus 1 over, let's say we have this x, open bracket, x squared plus x plus 2 as well, another form of this. Now of course, just like this top one, we're going to have what it's still going to be a over x, because that's just one form. Then we have the other one. Now this is factor of 2, also the same thing, so you're going to have it to be bx plus c over x squared plus x plus 2. All right, that's good. We've understood that, right? Because this is also not factorizable, because we're looking for factors of 2 that we add up to 1. That's just not possible. We have 2 times 1, 2. 2 plus 1 is 3, not 1. We have minus 2 times minus 1, and they'll give me minus 3, not 1. So I can have another case there. So that's how that works. So let's take another example. This time around, let me just make it a little bit more complex. Maybe we should have 2 quadratic expressions, because that's something that's possible. So let's say we have 2x squared plus 3x plus 1 over, say we have x squared plus 5x plus 1, and we have x squared plus x plus 2. So what are we going to have? We're going to have this is non-factorizable, this is non-factorizable. I took it from the first example and this second one. So what are we going to have for this one? We're going to have ax plus b over x squared plus 5x plus 1, and for the other one, which is also non-factorizable, we say cx plus d over x squared plus x plus 2, and we will work from there. That's how we start our work, like that. I hope this is making a little bit of sense here. That's how we start our work. And then let's go on. We still have, maybe let me just, okay, yes, in case we have a power of 3, how will that one look like? Let's say we still have our 2x squared plus 3x plus 1 over, let's say we have x minus 2, and we have x cubed. Okay, I have to confirm that this is non-factorizable. So let me just take an example from the textbook. Let's see. Okay, they said x cubed plus x squared plus x minus 1. X cubed plus x squared plus x minus 1. All right, so I'm not even going to check if it's factorizable or not, because I just took that from the textbook. So we're going to have a over x minus 2. So now remember, the reason why we knew that our quadratic, the one of power 2 quadratic expression was non-factorizable was because we divided our x squared plus 5x plus 1 by a linear factor, right? So that's why we decided that, oh yeah, and our result looked in this form, x plus 4. So we're going to do the same thing to this case here. Now we could just divide it by any linear factor that we have from there, just like I did that way. But I don't want to go through that stress, because I already know what the result is being. We're going to have a quadratic expression as the result, because we do know that the product of a linear and a quadratic will give us a trinomial expression. If that doesn't come naturally to you, I think you need a little bit of a checkup on your polynomials. But that's what we do have. When you take your power of x, your linear term, x squared term, and then expression there, we have a trinomial term. So if I'm doing the reverse of it, which is dividing this by a linear term, I will have a quadratic term, which could look like this. So the result will be generally of this shape to be bx squared plus cx plus d. So plus d over, what do we have? X cubed plus x squared plus x minus 1. So hopefully we don't get to solve a problem like this. So well, that's it for now. We will solve some questions with this partial fraction step in the next video, starting from the next video. And that's it. I hope you understand what I just explained. And that's it. Alright, so let's start. This question says resolve 3x plus 2 over x plus 1, x squared plus x plus 2 into partial fractions. So we have 3x plus 2 over x plus 1, x squared plus x plus 2. Alright, so let's investigate. We have this one to be a linear denominator, so that's still a over x plus 1. And then as for this one, our x squared plus x plus 2, this is a quadratic expression, so it could either factorizable or non-factorizable. So we just need to confirm, is it actually factorizable? What are the factors of 2 that will give us 1? That's not possible, because factors of plus 2 is either 2 times 1, 2 plus 1 making 3, or minus 2 times minus 1, and minus 2 plus minus 1 will give us minus 3. So since that does not give us this 1 that is here, then we know that yes, this is non-factorizable. So our resulting fraction numerator is going to be bx plus c over, what do we have here, x squared plus x plus 2. So now let's add it together. Now we're having this going to give us x plus 1, then x squared plus x plus 2, and here we have a open bracket what, x squared plus x plus 2, then we have what, bx plus c, take it with x plus 1. Then we have on the left hand side to still be 3x plus 2 over x plus 1, x squared plus x plus 2. Alright, so we now have what, 3x plus 2 is going to be equal to a open bracket x squared plus x plus 2, right? Then plus, what do we have here? We have bx plus c, and we have x plus 1. So we need to expand this one elsewhere, so that we could have our work here. So we have 3x plus 2 equals to, let's write this for one more time, a open bracket x squared plus x plus 2 plus, now let us expand this, bx plus c over x plus 1. So let's expand it. So we have open bracket bx plus c, we have x plus 1. So bx, we have x plus 1, then plus c, we have x plus 1. So bx times x is bx squared, plus bx times 1 is bx, plus c times x is cx, then c times 1 is c. So that's our expansion. So we have it to be okay, bx squared plus bx plus cx plus c after expanding. Right, so let us also expand this one. We're going to have 3x plus 2 will give us a times x squared is ax squared, plus a times x is ax, then plus a times 2 is 2a. Then we have it with bx squared plus bx plus cx, then plus c. Alright, so I think now is be a good time to group it by the power of x. So we group x squared, then x, then plus the constant terms. So we have this to be 3x plus 2 equals to, what are the x squared terms that we know? We have this one and this one. So you can say this is a plus b from bracket x squared, then plus, what are the x terms that we know? We have this one and this one. So we have a plus b will give us x, then plus, what are the c and the constant terms that we know? We have this one and this one. Okay, we have c here for the x term. Please don't make a mistake as well. So a plus b plus c. So what are the constant terms we have? We have this one and this one. So what are the constant terms? We know that is 2a plus c as well. All right, so let us count. We have 1, 2, 3, 4, 5, 6, 7. So we have 1, 2, 3, 4, 5, 6, and 7. So yeah, everything makes sense here. So it is 7. That means it is complete. So now it's time to do the comparing the coefficients stuff. Comparing the coefficients. Alright, so in this side we have what 3x plus 2. We have if you look here now, we have x squared here, but we don't have any x squared term on the left hand side. So that's like saying it is equal to 0, right? So as if it is 0, so we have 0x squared plus 3x plus 2. So that means your a plus b must add up to 0. So we had this here, that's okay, a plus b must be equal to 0, because those are your terms with x squared. So if we come back here, we see that here a plus b, here it was also give us a 3. Wow, that's a weird okay, yes, your a plus b plus c, because remember the c was there, must add up to 3. That is here, so you could have it that. Okay, so your a plus b plus c must give us a 3, and finally they said 2a plus c must give us 2, because that's the constant one. This one contains x, so that's why it is there. So this one and this one are the same, while this one and the constant ones are the same. So 2a plus c must be same as 3. So we know that 2a plus c must be equals to 2. So let's develop our equation. We have that to be equation 1, equation 2, equation 3. So just like previous examples I've showed for this particular method, it is just going to depend on a lot of wisdom to solve these 3 equations properly. And how do we exactly do that? So if you look at this now, I can easily tell that from my equation 1 that if you add a and b together, we'll get a 0. So I can substitute that information in equation 2. So if I substitute the addition of a and b, since I have it directly here in equation 2, I can easily get my c. So that's what I will do. And if I've gotten my c from equation 2, I can substitute it in equation 3 to get a, and finally I can get b. I guess that's what I will have to do then. So I will say, okay, you know what? From equation 1, a plus b will give us 0. So that means your in equation 2, a plus b plus c is equals to 3. So that means 0 plus c is equals to 3, and c must be equal to 3. I guess that's pretty much straightforward like that. So c is equals to 3 like that. Then the next step is substitute c equals to 3 in equation 3. The equation 3 says that 2a plus c is equals to 2. So we have 2a plus 3 must be equals to 2, and your 2a must be equals to minus 1 after taking it to the other side. So divide by 2 and divide by 2. Your a is equals to minus 1 over 2. So now that we've gotten a to be 1 over 2, we can substitute in equation 1 to get b. Substitute a equals to minus 1 over 2 in equation 1. So equation 1 tells us that a plus b is equals to 0. So minus half plus b equals to 0, and b is equals to half by the time we take it to the other side. So we've gotten a to be half, b to be a to be minus half, b to be half, and c is 3. So that means your equation here, that means your 3x plus 2 over, what do we have? X plus 1, x squared plus x plus 2, x squared plus x plus 2 must be equal to, what is a? A says 1 over 2 minus 1 over 2, so that's minus 1 over 2, open bracket, x plus 1 plus bx. B is saying 1 over 2x. Please, this time around, you don't drop the 2 there like that, because it's like saying half of x plus a constant, which is 3, over, now we have what? X squared plus x plus 2. Now, we could decide to actually even simplify this half x plus 3. Remember that half of x, 1 over 2x plus 3, your LCM can become 2. 2 in 2 is 1. 1 times x is x, plus 2 in 1 is 2, times 3 is what? 6. So that will give us x plus 6 over 2. So we could replace this half x plus 3 by x plus 6 over 2. And this time around, these 2 can now come down here, because the 2 is for everything. The reason why we couldn't take it down is because it was only for x here. So we could say, okay, that will give us minus 1 over 2, minus 1 over 2, open bracket, x plus 1, plus, we got x plus 6 over 2, open brackets. Where do we have? X squared plus x plus 2. Now, x squared plus x plus 2. Now, alright, it's also okay to actually write the one with the plus first before the minus. So we have x plus 6 over 2, open bracket, x squared plus x plus 2, minus 1 over 2, open bracket, x plus 1. And that is it. So we solved this, did this, and then we arrived at this. Isn't that beautiful? Alright, so let's move on to this other question. It says, resolve 3x squared plus 2x minus 1 over s squared plus 1, 2x squared plus 3x plus 1 into partial fractions. So here, in this case now, we have two quadratic expressions. We need to actually check if they are factorizable. That's the entire point. Alright, so what do we have? We have your alright, so the first step is to check if the fractions are actually factorizable. That's what you have to do, because if they are not factorizable, you have to use the entire system. So let's get into it. So we have solution. We have that our 3x squared plus 2x minus 1 over, we have what? X squared plus 1 over 2x squared plus 3x plus 1. So as it stands here, I already know that x squared plus 1 is non-factorizable at all. So since it is not factorizable, let me just use it with my ax plus b over x squared plus 1. Then plus this. Alright, so 2x squared plus 3x plus 1 is actually factorizable. But here, I am willing to argue that you could also solve your factorizable partial fractions denominators using the same system. Now, this is still kind of experimental for you. I just want you to see something that it would work as well. So let's see. We are going to have it to be cx plus d over, now we have 2x squared plus 3x plus 1. So let's actually let's solve it now from there. So what are we going to have? We are going to have this to be what? Our LCM is going to be x squared plus 1 and 2x squared plus 3x plus 1. Now we have ax plus b. We take up with this is going to give us this 2x squared plus 3x plus 1. Then plus this, we cut this and we have cx plus d, and we have x squared plus 1. So that's going to give us what? Your 3x squared plus 2x minus 1 over, we have what? X squared plus 1 and 2x squared plus 3x minus 1 plus 1 rather, like that. So working with the numerators, we're going to have 3x squared plus 2x minus 1 equals to, what do we have here? We have ax plus b and 2x squared plus 3x plus 1. That's 2x squared plus 3x plus 1. And then plus, what do we have here? We have cx plus d and x squared plus 1, like that. So the next thing for us to do is to actually expand the brackets. So what do we have? 3x squared plus 2x minus 1 equals to, now ax times 2x squared is going to give us 2ax cubed plus ax times 3x will give us 3ax squared plus ax times 1 will give us ax. Now let's go on. B times x squared will give us 2b x 2. Okay, b times 2x squared is going to give us 2bx squared plus b times 3x will give us 3bx plus b times 1 will give us a b plus, okay, that's all for there. Then we have cx times x squared will give us cx cubed plus cx times 1 will give us cx, then plus d times x squared will give us dx squared plus d times 1 will give us a d. All right. Sorry. So personally for me, I prefer to actually go out and expand things on my own, but you could also do it like this in the middle of your work, like step by step like that, but just ensure you are doing the right thing. All right, so the next thing for us to do is to actually group things out according to their powers and of x and everything like that. So we have 3x squared plus 2x minus 1 equals to, what are the things we have here? The powers of x cubed, probably first. So I have 2ax cubed plus cx cubed first. So that's going to be 2a plus c, and both of them are x cubed. Of course, you need to pay a lot of attention so you don't make mistakes, and you need to be aware of everything you are doing. So for x squared, now what are the ones we have? I have 3ax squared, I have b, and I have d. So I have what? 3a plus 2b, and I have what? D. So be the ones with x squared. Plus, now what else do I have? I need the ones for x. So I have ax, I have 3b, I have cx. So that's going to be what? Ax, x is a, plus what do I have? 3b, and I have what? C, all with x. Then plus, what do I have last? I think I have b and I have d. So that's what? B plus d, which are the constant terms. So let me count them. 1 2 3 4 5 6 7 8 9 10. 10. So I have 1 2 3 4 5 6 7 8 9 10. All right, so that's perfect as well. So let's move on. So what are we going to do now? We're going to start comparing the coefficients. So if you look at here now, we have x cubed here and we don't have any x cubed here, so that's going to be 0. So we have 2a plus c and 0 here, so we know that 2a plus c must give us the 0. So that's going to be 2a plus c must be equal to 0. That's our equation 1. Okay, moving on, we have that 3a, everything with x squared must give us this 3. So 3a plus 2b plus d. So we know that 3a plus 2b plus d must give us a 3. This 3 that is here, which is our equation 2. So the next thing we need to know is that the x term, a plus 3b plus c, must add up to these 2. So we know that a plus 3b plus c must add up to 2. So equation 3. And then the final thing is that b plus d must add up to minus 1. So we have b plus d must add up to minus 1, which is our equation 4. So in this particular examples, we have 4 equations to deal with. So let's let's solve. So my own idea, like I've said in an earlier video, is that it is okay for us to actually to break down our equations into two simultaneous equations that have the exact same two unknowns. So we are going to work gradually to have the two unknowns. And how do I want to achieve this? The first thing you need to do is to observe your four equations well, and just don't despair, because this part may not come easily and intuitive to you, but that's how it works. You need to just understand fully well. Something like, it's almost just you are waiting for the moment in which a light bulb will click in your brain and see exactly what I'm saying. But my goal, the overall goal, is that you want to work with only two simultaneous equations, and those two simultaneous equations must have the same two unknowns. If we look at equation 1, that's A and C. Equation 2 has A, B, and D. Equation 3 has A, B, and C. And equation 4 has B and D. From what I'm seeing here, I'm seeing some pattern. Equation 1 and equation 4 have completely different things. This one has AC, this one has BD. So I think what I'm going to do is that for equation 2, if I get something for D, maybe hopefully it's in terms of A or B. So if I get it there, then my D can disappear and I can only have A and B. And then if I get something for C, I can get something in terms of A and B, and then I can solve as well. So that means my equation 2 and 3 will now become two equations I can solve simultaneously, and hopefully I can get A and B. That's the idea I am going to use. So how do I go about this? I'll say, oh, okay, just observe my equation. For my equation 2 now, which I need to eliminate this D away, I can already see that, oh, my if I substitute with D here now, by taking B to the other side, I will have an expression for D which I can substitute. And yes, yeah, please, when you're solving, you need to actually have a little bit of constraint to your thinking here, because again, this is my classic leaping before looking, in which you have to look ahead before you actually do what you need to do. So in this case now, from equation 4, like I'm saying now, I know we could easily take anything. You can take B to the other side, or you could take D to the other side. But remember, what your target is that you want to make only A and B remain in equation 2 and 3. If you take your D to the other side, you will get an equation for B, and that way you still have D in the equation. I mean, it's not a bad thing as at all. It's actually it's actually perfectly valid. But the problem is that if you go and do the same thing if you remain D in your equation and you still want to solve for equation 3, remember there is no D that you would have taken for C here, so you still have the unknowns that you don't want. Do you get? I hope you understand what I'm saying. Let me say it again now. If you actually take this B to the other side and get an equation for D, by the time you substitute it back in equation 2, you will have an unknown in terms of A and D, while B is still there, right? And also, but by the time you want to do the same for equation 3, you still see that the two equations do not have the exact same unknowns that you really want to work with for your simultaneous equation. So I mean, it is better for you to actually know the overall strategy ahead of time. So once you know your strategy, you work towards it. I want to get an equation for D, and I want to get an equation for C. So if I get an equation for C and D and substitute, I will only have A and B. Hopefully, that's what I'm going to target myself with. So that's what I'm going to do now. So I'll say from equation 2, from equation not equation 2 now, from equation 4. From equation 4, I know that B plus D is equals to -1. By the time I take B to the other side, I will say D is equals to -1 minus B, which is going to my equation 5. And also, I can now say put equation 5 in equation 2. So I can handle that. So equation 2 told me that 3A plus 2B plus D is equals to 3. That's going to be 3A plus 2B plus what is D? That's -1 minus B equals to 3. So that's going to be 3A plus 2B plus times minus is -1 plus times minus is -B, which is equals to 3. So we have 3A. Now 2B minus B will give us a B, right? -1 to the other side will make it equal to 4. and that's the equation 6, right? So we have 3a plus b, which is equals to 4. And you can see what I'm saying. We only have an equation in terms of a and b. Now that's what we did from there. The same thing we could say from equation 1. Now we can get an equation in terms of c. So from equation 1, what do I have? 2a plus c is equals to 0. So c is equals to, take to the other side, minus 2a, which will give us equation 7. So we will now say put equation 7, which is another way of saying substitute in equation, which equation now? Equation 3. So if we put it in equation 3, you will see what the equation 3 told us, that a plus 3b plus c is equals to 2. So I have a plus 3b plus minus 2a equals to 2. So I have a plus 3b minus 2a equals to 2. Now a minus 2a is minus a, and we have plus 3b, which is equals to 2, and that becomes my equation 8 from there. So what do I need to do? I will need to solve equation 6, which is 3a plus b, which is 4, and equation 8, which is minus a plus 3b equals to 2. I'll solve the two of them simultaneously. So I will say solve equation 6 and 8 simultaneously. Solve equation 6 and 8 simultaneously. Alright, so equation 6 told me that we have what? 3a plus b equals to 4. So I have 3a plus b equals to 4. And equation 8 tells me minus a plus 3b equals to 2. So that's minus a plus 3b equals to 2. 3b equals to 2. So again, this is equation 6 and this was equation 8. So now what do I do? Let's say I want to eliminate b. What do I need to do? I just need to what? To ensure they have the same coefficient, which is equation 3 multiplied by 1. So that will give me 9a plus 3b equals to 12. And I have minus a plus 3b equals to 2. So to eliminate, they have the same sign, so I'll subtract 9a minus a, that's 9a plus a, which is 10a equals to 12 minus 2 is 10. Then I divide by 10 and divide by 10, my a is equals to 1. So I can now say, oh yeah, substitute a equals 1 in equation 6. My equation 6 tells me that 3a plus b equals to 4. So I have 3 open bracket 1 plus b is equals to 4. So 3 plus b equals to 4, and b is also equals to 1. So we have a equals 1, b is 1. So now that we've gotten a and b, we can rely on our equations and our equation 5 and our equation 7 to get d and c directly, respectively. So I have substitute a and b equals to 1, 1 equals in equation 5 and 7. So we say substitute a equals 1, b equals 1 in equation 5 and 7. So equation 5 tells me that d is minus 1 minus b. So d is minus 1 minus b, which is minus 1 minus 1, and that's minus 2. And c tells me it is minus 2a, if I remember correctly. Oh yeah, that's correct. So minus 2a, so that's minus 2 open bracket 1. Suppose that's minus 2 as well. So we are done solving. We've gotten a and b, c and d. So all we just need to do now is to put it in our mock-up solution, and that is, our solution is what? 3x squared plus 2x minus 1 over, what do we have here? X squared plus 1, 2x squared plus 3x plus 1. It's going to be a. Okay, remember this is saying ax plus b. Since ax is 1x, that's x plus 1 over, what do we have here? S squared plus 1 here, then plus, what do we have here? Cx plus d. So that's cx plus d over this. So that's going to be 2x squared plus 3x plus 1. Cx is going to be minus 2x minus d minus 2x minus 2. So that's that. So because of, we could factorize by minus 1 here because both of them are minus 1. So that's going to be x plus 1 over x squared plus 1, then plus minus 1. Then we have, once we do that, we have 2x squared plus 2 over 2x squared plus 3x plus 1. So of course that also, we can take that to be a minus here. So that's x plus 1 over x squared plus 1 minus, what do we have here? 2x squared plus 2 over 2x squared plus 3x plus 1 as well. So because this plus times minus is minus. And yeah, wonderful, we are done. So it only took us 19 minutes to finish this problem, but we indeed finished it. So yeah, and I can also verify that that is exactly what the textbook got, and we are perfectly correct. So that is how to solve a partial fractions in this. You equate your this thing, you get a bunch of equations, you make some mathematical wisdom to ensure you have two simultaneous equations like that, and when we get the simultaneous equations, we solve, and then we get our answers. So yeah, I hope you really enjoy it, and I really look forward to you solving your own questions as well. And that's it.